All right, wasn't that fun? Okay, so I chose to put my flashlight 30, 40, 50, 60, 70 centimeters away from the lens, and the note card focused an image at each of these image positions. Notice I do everything in centimeters. You can do optics in any length units you want, as long as you keep the same length units all the time. And okay, so now I'm realizing that this is a mistake. This should actually, that is not a mistake. That is in, nope, that should be in reciprocal centimeters. Sorry, folks. That should be in centimeters to the -1 and centimeters to the -1, or 1 over centimeters. Oops, whatever. Okay, so there we go. Now I'm going to make a plot of image distance versus object distance, because this feels like the dependent variable. And let's just plot these two and see what we get. All right, here we go. So image distance and object distance, you'll notice that we get this curve. And you may be fooled into thinking that this is a reciprocal curve. But here's the problem. This is not a reciprocal curve because it doesn't have asymptotes on both axes. This curve is more like this. And so what that means is that the curve maybe is more like this is one of the asymptotes, and that is one of the asymptotes. Notice that the asymptotes are the same number, 20 and 20, but they are not 0. A reciprocal graph has asymptotes at 0 and 0. That is not what this is. This is a graph where the asymptotes are the same number, but just not 0, maybe 20 and 20. Or maybe 15 and 15, who knows, right? Okay, we haven't done the data enough to know yet. However, if I make a graph of reciprocal of the image distance and reciprocal of the object distance, I actually get a line. That line has a slope of -1. It's supposed to have a slope of -1. You're looking at this right here. That's almost -1. That's because for any lab you do, for any lens or mirror, you should get a slope of -1. I'm going to show you why that is. It's the intercept that winds up mattering. It's the intercept that I care about. In this lab, it's the intercept that matters, not the slope. The slope will be -1 no matter what lens or mirror I use, but the intercept, that's what's going to help me get the focal length. So I'm going to show this to you right now. I have to write up here, so here we go. The basic equation is 1 over S0, that's the SO, that's the image object distance. 1 over the image distance equals 1 over the focal length. On the graph I just showed you, 1 over SO was the horizontal, and 1 over SI was the vertical. And the focal length of the lens is a constant. It's just going to be a constant, so I'm going to put C there. Watch as I bring it over. I'm just going to bring the x over. Y equals C minus x. Well, what is y equals C minus x? It's a graph with a slope of -1 minus x. That's a -1 slope. And where C is both the horizontal and the vertical intercept. So on the graph I just showed you, the C would be 0.0577. That's the vertical intercept, and because the slope is -1, that is also the horizontal intercept. But notice the intercept is not the focal length. The intercept is the reciprocal of the focal length. Focal length is the reciprocal of the intercept, either one. Horizontal or vertical should be the same intercept. So if my intercept was 0.0577, then the focal length was 17.3. And that would be where the asymptotes are located on this graph of image and object distance without any reciprocals. I have an asymptote at 17, an asymptote at 17. That is not a reciprocal function. It looks like one, but it's not. All right. That was for the mirror. That was from the mirror I got. This is for the magnifying glass. So this is my sample data for the magnifying glass I bought at Dollar Tree. So let me erase and let you have a look at it here. Again, 30 through 70 for me, and my image distances were much closer than for the mirror. Students need to know that if image distances are closer, then that object has a shorter focal length. They just kind of need to know that concept. Okay, so here we go. I got my curve again. It's not a line. Here I got my line again. again. This was not good at all. If you look at this slope, that's nowhere near -1. I mean, it's -1.34. It should be -1. So that means I did not do a good job of taking data, in my opinion. In this lab, the good job of taking data is all about having a slope very close to -1. So you can take the reciprocal of the intercept, but for me, I think that that's going to be loaded with error. What did I get here? Since the intercept was 0.0778, my focal length is about 13 centimeters, but I would want to go back and try this lab again. Or maybe I would take the reciprocal of this intercept and the reciprocal of the vertical intercept. So the vertical intercept and the horizontal intercept, do two different reciprocals, get two different focal lengths, and then just average them together. That might be the real focal length, I don't know. This lab only works with converging lenses or mirrors. It does not work with diverging, like the objects in the mirror are farther than they appear, closer than they appear mirror. It doesn't work with that. Please, 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 please do this problem with your students. This is what it has looked like on the 2 released AP Physics 2 exams. Do this problem with your students. That's how this lab will look on a Physics 2 exam. I'm sorry about that. Let me correct that. On a Physics 2 exam, yeah, it came from a Physics B exam, but on the Physics 2 exam, it's only appeared on the multiple choice so far. But if your students have done the lab and they understand it, then they should be able to answer the question. It may show up on a free response. We never know when. Okay, so that's all I've got to say to you about right now. Please do this lab. And then I will see you next time for physical optics.